I'll now take a very basic look at using VOPs and KineFX, and for this example we're going to be building a very basic spine system. This is going to be a 4-bone spine. This is because most of the rigs I'm working on are for games. I'll enter my geometry node. I'll add a line node. This line is currently a 2-point line and I will leave it as it is. We will instead add points to it using a resample node. I do not want to change the length of the line, so I'll divide the line using maximum segments, and I'll uncheck maximum segment length. I'll set the number of segments to be 4. This will essentially give me 4 bones. We'll have the hips, the spine, the chest, and the upper chest. I can then duplicate the resample node. This resample node will have 3 points, and these points will be the controls for the rig. These controls will be the base, the middle, and the tip. I'll now add transforms to these points, and I'll use a reorient joints node to do this. I'll then add a name node to name the joints. The class should be points. There will be 3 points. The first will be the base, the second will be the middle, and the third will be the top. I'll then create my controls. I'll start with the controls node. I'll set the control type to be circles, and I'll align it along the XY plane. Add a name node, and we'll give this the name attribute IK. To link the controls to the rig, we'll get an attached geometry node. I'll just attach this control to all the points, and the control's name will be IK. I now have my basic control set up, but I do not like the way these points are parented. I want the base control to be the parent of the top control, and I want the middle control to be a child of the top control. I will now get a reparent joints node. I'll add 2 options to reparent. The first will reference all the controls, and this will be used to remove all parenting. For the second one, I'll select the middle joint, and this will have its parent set as the top joint. This setup can now be tested using a pose node. My base can now be moved independently of the other controls. The middle control will also move independently, but the middle control will still follow the movement of the top control. I still want the top joint to be the child of the base joint, but I want to be able to switch between that behavior and the current behavior. So I will get a switch node. I will then create 2 branches from the reparent joints node to the switch node. I will get another reparent joint node, and I'll attach this node to the first of these 2 branches. This reparent joint node will reparent 1 joint. That joint will be the top joint, and the parent will be the base. I can now switch between having the top of the spine follow the base, or having the base move independently of the rest of the spine. So this will be my basic IK setup. I can now work on the FK branch. Once again, I'll use the reorient joints node to create the transformations for the joints. For the names, I'll use an attribute wrangle node. I'll create an attribute name. I'll create the name using a function called sprintf. This is basically the same as the printf function, which you'll use to print to the console. The only difference is this will print to a string. The main part of the name will be spine, underscore. I'll then add an integer to the string with %i, comma. I can then set my integer, and I'll set it with an attribute, and this attribute will be pt_num. This will give us the point number. I can now look under my geometry spreadsheet. The points all have a name attribute, and the name is spine. This is of course a long-winded way of setting this up. An easier way would have been to use the rig doctor node. With this node I would rename the prefix to spine. If I was using this method, I would initialize these transforms within this node as well. For now, however, I'll stick with the attribute wrangle, as it's useful to be able to approach things in different manners. I'll then add an attached control geometry node so that I can create controls for the FK. I'll generate my control using a control node. I will then use a name node to give these the name attribute, and this attribute will be set to FK. I will add one control group in the attached node. This will affect all points, and it will attach the FK controls to them. I'll then set the controls to circles, and I'll resize them. I can then add a rig pose node. I will then lock the translate parameters on each of these points. We can now work on our solver, and for this solver we will use a rig attribute VOP. It is also possible to do this in VEX. However, for rigging, VOPs are far more easy to implement. The IK will go into the first input, and the FK will go into the second. We can then enter this node, and the node we're going to be working with is the curve solver node. By default, the curve SOP will use the most basic setup. We are reading all the points from the first input. These are the target points, and these are the points which will be deformed. We're then reading all the points from the second input, and the curve solver will use these points to drive the deformation. By default, all that is required to get this node to work is to set the output. There are two options to set joints in KineFX. The first is set joint transform, which will work on a single point, and we will be using the set joint transforms, and this will work on an array of points. We can then connect this node using the points and the transforms from the curve node. The curve is now being deformed, but this is not our desired behavior. The reason it isn't working correctly is that the curve node needs to know what kind of curve I'm passing into it. In this case, I'm using polygons, and it is looking for a Bezier curve. I will not be using a Bezier curve. I will keep this as polygon lines. This is because I want my behavior to be closer to a traditional rigging hierarchy. This curve solver has quite a few options which you can use, and there's a number of ways to manipulate it, like squash and stretch. I will not be going into these in any depth at the moment though. We can now look at the more manual way of setting this up. When you're in the VOPs node, you can use drag and drop to get individual point transforms. However, when you're working with the curve node, you want to be working with arrays. So instead, I'll use the get point transforms node. Once again, this will be selecting from the first input, and I'll use a wildcard to get all the points. Although in practical use, it would be better to set up a group beforehand and use that instead. I will then connect the output points to the target points in the curve solver. I can then add a blend transforms node. I'll plug my point transforms into the first blend value, and I'll plug the curve transforms into the second value. I can then plug this into my set point transforms, and now I have a spine that will blend between my IK spine and my FK spine. And that will give you your basic spine setup. There is, however, one problem with this setup. When using this in an actual rig, you would want to make sure that the base point for the FK and the IK is the same point. Here they can be separated, but since this is an illustration, it should not be too much of a problem. And that's basically how you would set up a KineFX solver in VOPs. KineFX actually has quite a few solvers, and it's worth taking a look at them. The setup is usually pretty straightforward and doesn't deviate that much from what I've done here.